So now that we understand how to do simple linear regression in SPSS, let's turn our attention to something a bit more complicated. It's called multiple linear regression. But although it's more complicated, it's much more real world. You know that other things can affect job satisfaction besides just burnout. If we add more variables to our equation, we're going to come up with a much better equation, something that is much better able to tell us and predict for us levels of job satisfaction or whatever it is that we're trying to predict about the real world. So we're going to continue to use this job satisfaction.sav data set, only this time, instead of predicting job satisfaction only with burnout, we're going to add two more variables, compassion fatigue and compassion satisfaction. So let's go to SPSS. Using dataset jobsatisfaction.sav, here is how we're going to run a multiple regression. Go to the Analyze menu and choose Analyze Regression Linear. Let's click Reset, and then we'll put our variables in a slightly different way. Let's also practice a skill that we've learned before. Either right-click or control-click on any of the variable names and choose Display Variable Labels. Okay, we're going to predict job satisfaction. So job satisfaction is going to go into our dependent list. And we're going to use burnout to predict job satisfaction, so that will go in the independent list. So far, it's exactly the same as what we set up last time for our simple linear regression. However, we're going to create blocks of entry for each of the variables. So now click Next. In this second block, we're going to enter our second variable, which is compassion fatigue. Compassion fatigue goes right there. And we're going to create a third block, so click Next. And now we're going to enter compassion satisfaction. That will go into our third block. And in all of these, we're going to leave the method set to enter. Now, click on Statistics. We want to get the R-squared change and the descriptives for these three models. Click Continue and click on Plots. We also want to be able to examine the residuals left over after our multiple regression predictions. So let's get residual plots for histogram, normal probability plot, and we're going to create a scatter plot using Z predicted on our y-axis and Z residual on the x-axis. So we're going to move those two variables into the spaces for y and x. And don't worry, I'll explain more about what this is when we get to the section on interpreting the residuals. So now click Continue and click OK. There's our output. Let's go back to PowerPoint and look at this output a bit more closely. The first thing that we find are the descriptive statistics. These give us the means, standard deviations, and sample size for each of the variables. Below that, we find correlations. Remember, anytime we do a regression equation, it will also calculate a correlation. And we can see the correlations among all of the variables going into our model. So let's scroll down a little more, and we'll find the variables entered/removed block. This shows us what variables were entered at each step in the model. We started with model 1, burnout, then we added compassion fatigue, then we added compassion satisfaction. So really what we have are three models, and we want to know which one works best. The best model is going to be the model that explains the most variability with the fewest number of assumptions, or the fewest number of variables. So with model 1, as we check our R-squared values, we see that model 1 explains 42.3% of the variability. That we can see from the R-squared value. But as we go to model 2, the R-squared is 44.2, model 3, 44.5. That's not much of a jump. Adding those other two variables did not do much to improve our model. Model 2 probably better than Model 1, but we can check and find out for sure. Model 3 doesn't look like it's going to be much of an improvement. As we look under the change statistics, we find that the change from nothing to Model 1 was a 0.423. That was a big bump. The next bump was 0.019. Well, let's see, was that much of an improvement? Go to the right, and we'll see that under SIGF change, we see that the significance for that second model is 0.010. Well, all right. That tells us that it was a statistically significant improvement. But now let's look for the change statistics on Model 3. Model 3, adding compassion satisfaction, the R-squared change was a 0.003, not much of a change, and it was not statistically significant at a value of 0.335. So what we would conclude is that Model 2 is an improvement over Model 1. But Model 3 is not a significant improvement over Model 2. We can see more about that as we examine the ANOVA tables. Now, in this case, the question is whether this model is a statistically significant predictor of outcome. So we're not looking for the significance value here comparing one model to the next, only whether the elements in this model are statistically significant predictors. What we've already decided is that Model 2 is the best. It describes the most variability with the fewest number of variables, in this case, 2 variables. And it is statistically significant in its predictive ability. So we will interpret off of Model 2. What this table tells us is that all 3 models are significantly better than nothing, but Model 2 is more parsimonious, explaining more variability with fewer variables than Model 3. So we will then use Model 2, and we will plug in now an A and 2 B values into our regression equation. So now our regression equation becomes y hat equals 222.65 minus b1 times x1, where b1 is a negative 2.45, and x1 is a value we will plug in for a score on burnout, plus 0.60 times x2, that will be a score for compassion fatigue, which we can plug in later, plus some error. We will not include B3 for compassion satisfaction because Model 3 is non-significant. We will only include the coefficients for burnout and compassion fatigue in our final model.